Hello everyone, and welcome back to another video. In this video we're going to tackle some example problems that involve applications of quadratic equations. So let's suppose that the dimensions of a trading card are 4 inches by 6 inches. The card is to be encased by acrylic that is 1.5 times the area of the card. Determine the dimensions of the acrylic that will ensure a uniform border around the card. So notice I've got this somewhat uniform looking border around the card, and essentially what we need to do is just determine the dimensions of this acrylic that gives us this border. So here's how we'll approach it. We'll take each piece of information that they give us. So first notice that they tell us that, let's use the drawing tool, they tell us that the trading card's 4 by 6, so we know that the area of this is 24 inches squared, because that's 4 times 6, and they're telling us that the card is being encased by acrylic that is 1.5 times the area of the card. So the acrylic, the area of the acrylic is 1.5 times the area of the card, which is 24. So we've got 1.5 times 24. If you throw that in your calculator, you'll get 36. I guess I should put inches squared here and here as well. So we want the area of the acrylic to be 36 inches squared. So let's think about what we need to solve for. Well, we need the dimensions of the acrylic, so what's really missing is this uniform length, say here, maybe I'll use a different color, purple. Notice that this length, this length, this length, all of these are the same length because of our construction. We wanted a uniform border. So let's just call one of these sides, we have 8 of these sides, right? But they're all the same, so let's just call one of them x. We want to know what x is, because as soon as we know what x is, say here and here, then to calculate, say, the length of this box, it's just going to be 4 plus, or x plus 4 plus x. Similarly, the width of the box, of the acrylic casing, that is, that is x plus 6 plus x. So let's write some more stuff down. So in particular, we have that the casing's dimensions, we know that the width is equal to x plus 6 plus x, or in other words, you could just say 6 plus 2x, that's the width, and the length is x plus 4 plus x. And then this is for the acrylic, I should say, just to be clear what we're talking about. For the casing. So this is equal to 4 plus 2x. So the area of the acrylic casing is again, it's just the length times the width, just like it is for the little square, except now we've got to multiply these more complicated looking things. We have to multiply 6 plus 2x, the width times the length, 4 plus 2x. And remember that the length times the width is the area, and the area of this acrylic is 36 inches squared. And I'll omit units in these calculations. Okay, so now we've just got to solve the quadratic equation that results from this. So let's go ahead and multiply everything out, and maybe I'll actually select this and pull it up a little bit, a little higher. There we go, that's a little better. Give myself a little bit more room. So let's go ahead and distribute everything through. 6 times 4 is 24. 6 times 2x is 12x. 2x times 4 is 8x. And 2x times 2x is 4x squared. And one more thing, I'm just going to kill two birds with one stone. I'm going to subtract 36 from both sides as well in this step, just to save a tiny bit of time. And that will, of course, make the right-hand side, let me pan a little bit to the right, that will make the right-hand side of this equation equal to 0 because we've subtracted, because we've subtracted 36 from both sides of our equation. And now let's just, combine like terms. We've got a 24, we've got a minus 36, that gives us a minus 12. I'll throw that over here. We've got a 4x squared by itself, and then we've got 12x and 8x making 20x. Now this is very nice because we have a common factor of 4, so we can pull that out. And now we're going to get two solutions from this. Notice that this isn't factorable, so our solution's not going to be particularly nice. So the lesson here is I should have more carefully chosen my numbers, but in order to not have to use more advanced techniques that we haven't learned about yet. But essentially, once you're at this step, you can just take what you have and factor it, and then only one of those solutions is going to make sense. You just take the one that makes sense, and that's the correct answer. And what I really mean is that one of them is going to be negative in this case. So I'm gonna just solve it just for brevity, but this is using something that's coming up in chapter 8, so don't stress about it too much now. It's called the Quadratic Formula. So this would mean that x is equal to negative 5 plus or minus the square root of b squared, that's 25, minus 4 times a is 1 times c, which is minus 3, all over 2 times a, which is 2 times 1. Okay, and if we just simplify this a little bit further, we get negative 5 plus or minus the square root of 25 plus 12, because the two negatives make a positive, so we get 37 over 2. And now notice, we got, like I said, we're going to get two answers out of this, but one of them is going to be negative, so it's not really going to make sense in our problem, so we only consider the positive one. And the positive one comes from this plus sign instead of the minus in our plus or minus sign. So we get, maybe pan a little bit more to the right, we get negative 5 plus the square root of 37 over 2 only. I'll write it, but we're going to cross this off in a second. We throw out minus 5 minus root 37 over 2. So this one doesn't count because it's negative. So this is our solution right here. And to be honest, I'm not quite sure what that is, but you could type that into a calculator and get some value. It should be approximately 1/2, just by the fact that the square root of 37 is really close to 6. It's a little bit more than 6. So if you plug in 6 in its place, you get 1/2, but it's probably going to be a little bit more. But anyway, I'll leave that to you if you're curious about more exactly what that value is. Yeah, so anyway, now they were asking us to determine the dimensions of the acrylic. So the acrylic here is going to be, remember, we've got the width and the length here. Width and the length. The width is 6 plus 2x. The length is 4 plus 2x. So the dimensions are a little bit ugly to write, but I'll write them. The width is 6 plus 2 times that whole thing, minus 5 plus root 37 over 2. And notice something nice happens. These 2's cancel out. So we've really just got 6 plus minus 5 plus root 37, which is the same thing as just 1 plus root 37. For the length, remember the length down here is 4 plus 2x. So we have 4 plus 2 times negative 5 plus root 37 over 2. But again, these 2's cancel. And we just have 4 plus negative 5 plus root 37, which is negative 1 plus root 37. Notice this is still a positive number. Both of these, with the width and the length here, are still both positive numbers. So these are the dimensions. We have a 1 plus root 37 width and a minus 1 plus root 37 length. So just for some approximate values, this is about 7.1 about, let's say, and then this is this is about 5.1. Okay, so that's the first problem. We've just determined the dimensions, and I guess I should use units, inches. So these are about the dimensions here. Okay, so that's problem number 1. A lot of the complication in that problem, again, came from the fact that I just chose the numbers off the fly. I didn't nicely construct this problem, so I apologize for that. But anyway, let's go ahead and look at another example. Here the numbers will work out much nicer, I promise you. So they tell us a wire is stretched from the ground. So imagine we're at the ground here, and it's stretched from the ground to the top of an antenna tower. So this is my red antenna tower, as shown. And the wire is 20 meters long. The height of the tower is 4 meters greater than the distance d from the tower's base to the bottom of the wire. So we've got the wire here. They're starting here and going up to the top. And then the base here has a length d. And they're telling us that the height is 4 meters greater than d. Writing that out, that means that the height here is actually, maybe I'll use a different color. The height here is actually d plus 4, based on what we just said. So now we have to answer. We have to find the distance d, and we have to find the height of this tower. Well, because we have a right triangle, we are going to use what's called the Pythagorean Theorem. Remember that the Pythagorean Theorem tells us that if we have a right triangle, then the two shorter sides, if we take the two shorter sides, square them and add them together, we get the longer side squared. This is what I mean more particularly. Just kind of in a generic form, we have a squared plus b squared is c squared. That's the Pythagorean Theorem. And now we substitute in our values. We have d plus 4, and 20. So we have, use different color, let's use blue. We have d squared plus d plus 4 quantity squared is equal to 20 squared. Well, let's use the fact that, let's use a little bit of what we know about simplifying binomials squared. We get d squared. We get plus 2 times 4 times d. So 2 times 4 times d plus 4 squared, which is 16. And then that equals 20 squared. So I'm going to take this and just pan it down since we don't need the stuff above anymore. This is getting a little bit sloppy looking, my apologies, but let's simplify this. We've got d squared, those add to make 2d squared. We've got 2 times 4 times d, that's 8d. And we've got plus 16, and then we can subtract 20 squared. 20 squared is 400, so really we've got 2d squared plus 8d, and then it's 16 minus 400, so it's going to be negative 384, I believe. Okay. Now, what's nice is notice that there's a common factor of 2, so we can factor that out. That leaves us with d squared, or I can just divide both sides by 2, and that gives us d squared plus 4d minus, what's 384 divided by 2? What's that, 192? Nice. All right. So now the question is, what are the factors of negative 192 that are going to add to give us positive 4? And this is kind of tricky. So let's go through the process. Remember what we do. We take that number minus 192 and we consider all of the factors. So let's just start from the very beginning. 1 times negative 192. Actually, let's instead consider 192 times negative 1, because again, remember, we have to add the two numbers to get a positive 4, so we need the larger number to be positive. Also notice we could do, if we divide it by 2, it's going to be, what's that, 96 times negative 2. But again, that one fails because those two numbers don't add to 4. I'm going to pan down a little bit. And notice that if we just keep on going, we can get 3 goes into it 64 times, I believe. So 64 times negative 3. I encourage you to use a calculator during these steps because it is a little bit intense with the mental math. 4 goes into it as well, I think. How many times though? I think it's 48 times. So 48 times negative 4. I'm still not quite to positive 4 when I'm adding them together, so we got to keep on going. There's also 6 times 32, I believe. So 32 times negative 6, that is. And we're almost there. I know I'm going to miss maybe 1 or 2 in between here. But here's one thing you can do. I can just take this 32 and cut it in half. That gives me 16. And if I'm cutting that in half, I must double the other one. So 16 times negative 12. So I cut the left number in half and I doubled the right number, and that's going to give me the same product in the end. So now I can just write this as d plus 16 times d minus 12 is equal to 0. And when we solve this equation, remember the principle of zero product says that in order to multiply two numbers together to give us 0, one of the two numbers, or both, must be 0. So we would have d is equal to minus 16, or d is equal to 12, But again, remember when we're working on word problems, we have to be careful about the context that we're considering. And negative 16 for a distance doesn't make sense, so we cross that one out. We really just have d is 12, and to use units, d is 12 meters. So that's the distance d. They'd also like us to find the height of the tower, but remember the height of the tower is just d plus 4. So the height is d plus 4, which is 12 plus 4, which is 16 meters. All right, so we've just solved a couple of somewhat involved word problems. I hope that this was helpful. If you have any questions, please leave them in the comments. I'm very happy to answer any questions that you have. And I hope you all have a terrific weekend, and I will see you in a future video.